Hello everyone, I'm Hyunji Hong from Korea University. I'm gonna present about the paper, Dicos, discovering insecure code snippets from Stack Overflow posts by leveraging user discussions. This study was co-authored with Seung-woo Nu and Hijo Lee. The goal of this paper is to discover insecure code snippets from Stack Overflow posts. These days, Stack Overflow is a daily part of a lot of developers' lives. Developers usually copy and paste code snippets from online Q&A fora such as Stack Overflow for their efficiency. However, reusing code snippets without understanding can cause several problems. It can compromise the security of the software and also cause the propagation of insecure code snippets. As a motivating example, let me introduce a post which is an example of containing insecure code snippets propagated to the Linux kernel. Here is the history of the post. The answer was first posted in 2008, but there was a security issue and the post was finally patched in 2018. The first answer post has adequately addressed the question in terms of functionality. However, user discussions revealed that the post had security issues such as null pointer dereference issue and undefined behavior issue. And these issues can compromise software security and functionality. Applying those comments, the code snippet was finally patched with a safe version in 2018. Like this motivating example, it is important to discover insecure code snippets in advance. However, existing approaches cannot discover these insecure code snippets accurately because they are only targeting security-sensitive APIs or cannot discover automatically. To resolve such problems, we propose Dicos, an approach for discovering insecure code snippets in Stack Overflow posts. The key idea of Dicos is an accurate approach by examining the change history of Stack Overflow posts for discovering insecure code snippets. Dicos comprises the following three phases. First, Dicos extracts the diffs, which is change history between the oldest and the latest from the post. After that, Dicos analyzes the extracted diffs, whether it is intended to fix a secret issue based on the three features. Based on the analysis results, Dicos determines insecure posts in phase 3. In first phase, Dicos collects Stack Overflow posts and then extracts all the change histories of each post. Dicos extracts the differences between the oldest and the latest revision of each code snippet, description, and comments in a post. Since a single post can contain multiple code snippets, a simple diffing method can extract the erroneous change history from completely different code snippet pair. To resolve this problem, Dicos proceeds with the code snippet pairing process. First, from every code snippet in the post, Dicos extracts all functions and cleaves them. After cleaving them, Dicos measures the similarity score between the oldest and the latest code snippets and pairs in order of highest score. As a result, Dicos can extract accurate code diffs through this pairing process. Before we talk about phase 2, we need to talk about feature selection. To avoid discovering only certain types of vulnerabilities, we selected the appropriate features which are prominent only in insecure codes through large-scale empirical study. Referring to related approaches, we selected 6 initial features. And then we conducted an empirical study on whether each feature appeared in a CV patch or a general code patch. From then results, we selected F1 feature because F1 appeared at a rate 4 times higher in security patches than in general code patches. Next, we selected F2 and F3 features, which appeared at a much higher rate in security patches than in general code patches. To sum up, we selected 3 features: changes in security-sensitive APIs, changes in security-related keywords, and changes in control flows. Now, let me explain how Dicos analyzes posts using selected features. When analyzing code snippets, Dicos uses F1 and F3 features. Dicos checks if deleted code lines contain security-sensitive APIs, or checks whether the diffs contains a change in control flows or conditional statements. In analyzing descriptions and comments, Dicos uses F2 feature. To avoid detecting non-security changes like example 1, Dicos checks whether each sentence contains keyword pairs. In our paper, Dicos considered a set of nouns and verbs or a set of modifiers and verbs as keyword pairs. Like example 2, if there is a keyword pair in the diffs, Dicos detects the post. Thus, Dicos collects each feature from the post and determines that the post with 2 or more features is insecure in phase 3. Let me explain about the evaluation. To collect Overflow post data, we used ESOTorrent dataset provided by Google BigQuery. We collected all answer posts, which is tagged with C, C++, and Android. Among them, about 670,000 posts were satisfied with our dataset, which posts contain at least one change history. Dicos discovered 12,458 insecure posts. For measuring accuracy, we manually verified the discovery results following 5 groups. We verified secure and insecure posts, which was found by Dicos, and as a result, Dicos showed 91% precision, 93% recall, and 89% accuracy for insecure post discovery. If you want to know more about the accuracy measurements or the comparison results with the existing approach, please refer to the paper. Now, we have 3 questions to talk about. The first question is about the correlation between the post creation time and the security of the post. Interestingly, we confirmed that the proportion of insecure posts accounts for about 2% each year. As insecure posts are constantly being uploaded to Overflow, the need for an automated approach like Dicos will increase. The second question is about the correlation between the post acceptance and the security of the post. In general, users are more likely to think that accepted answers are more reliable than non-accepted answers. However, we confirmed that the ratio of insecure posts was almost the same between accepted and non-accepted posts. It means that even if the post is accepted, developers need to verify a code snippet, and Dicos can help this verification process. The third question is about the types of insecure code snippets. We manually examine the insecure post with all three selected features, which is discovered by Dicos. Unlike previous approaches, which are only discover specific types of insecure code snippets, Dicos can cover various types of insecure code snippets like undefined behavior, buffer overflow, and more. To conclude, we presented Dicos, which is an accurate approach for discovering insecure code snippets in Overflow posts by leveraging user discussions. Equipped with insecure code snippets discovered results from Dicos, the credibility of Overflow can be improved by addressing discovered insecure code snippets, and further, this can create a safe code snippet reuse environment. This is the end of my presentation. Thank you for your attention.